WSIT Security. So here we are going to talk about WS Security Standard, and we're going to also talk about WS Trust and STS Security Token Service, and we are going to see what is and why WSIT Security Profiles, and then we are going to see some of those security profiles. So what is WS Security? So WS Security is supported by multiple specification, which includes WS Security and WS Security Policy specification. This is where how you can specify your security requirement for your web service using WS Policy statement. And WS Trust, this is for brokering security, and then Secure Conversation. So let's talk about the first standard, which is WS Security. So this spec provides industry standard for framework SOAP-based level security. So it defines how security information is going to be transported as part of the SOAP header structure. Okay, and it does support the multiple security token formats, so which includes username token and Kerberos tickets and X.509 certificates. And it uses underneath XML digital signature and XML encryption standard. So before WS Security, the security that is supported, the only security that you can use with your web service is using SSL, basically HTTPS. Okay. Now you can think of this as security at the transport layer. Okay. So it is all or nothing granularity. What it means is that suppose if you want to send your message in encrypted form to have a privacy, regardless of the size of the data, suppose you got 1 million bytes of the data, like a purchase order, you don't want to encrypt every single byte of that 1 million purchase order the document, because not every information it needs to be secure, and using SSL is very expensive. Okay, to encrypt your data is very expensive. The only information that you might want to secure is maybe credit card information. Everything else, it's not that, it doesn't really matter that much. So in that case, you might pick and choose only the data that you want to encrypt, so that you have less overhead in terms of performance. Okay. Another constraint of another constraint of SSL is that point-to-point. Okay. Which means if you are sending your SOAP message from one endpoint to another endpoint, and if there are intermediary nodes, then in each of those nodes, SSL has to be encrypted and decrypted and encrypted again. So that could be, in fact, a point of security failure. Well, again, these days, the web services are still being used point-to-point, so it's pretty rare still have intermediary nodes in typical SOAP-based environment. Okay, but this could be still a constraint. So that's the reason WS Security was introduced as a standard. It is again based on XML digital signature and XML encryption standard, which are from W3C. And the key point of WS Security is that instead of actually depending on transport layer, you are going to provide security credential information as part of your SOAP message. Okay. So it is actually providing security at the SOAP messaging layer. Basically, SOAP header will contain security information. So fine granularity is possible. So by using XML signature and XML encryption standard lets you in fact pick and choose the fragment of your data for encryption. So you can have a fine granularity in terms of what to sign and what to encrypt. Okay. And it should work on non-TCP/IP transport as well, because you're basically having security information as part of the SOAP message. So you can actually send SOAP message using whatever transport protocol. Okay, and it does support integrity, confidentiality, and authentication. Pretty much all security features are supported through this SOAP layer, the security. So SOAP message should contain all the security information as part of the message, so it doesn't depend on transport. However, in production environment, you might in fact actually use both the transport as well as SOAP level security. So that is still allowed. Okay, so in fact, one of the security profile is in fact combination of those two. So if you want to leverage SSL as well as SOAP level security, that's still possible. So this is a client, and this is the service, and you can see the message contains information about the security. Okay, so WS policy and WS security policy. As I mentioned before, WS policy, as we have seen before, WS policy specification just defines the syntax of how to write the policy statement and how to combine operate those things like the all or exactly one and things like that. Now, domain specific policy specification now defines a concrete set of policy elements that are relevant to that particular domain, in this case security. So you're going to see security specific the policy statement that again will be included in WSDL document to have security with your SOAP based web services. Okay, so that is basically what I just talked about. So WS security policy defines policy assertions that can be used to describe security capabilities and requirements of a web service. Okay, so these capabilities and requirements can be published as part of the WSDL. Okay, now when the client receives this WSDL, which contains this the web services security policy assertions inside the WSDL document, the client of course has to be compliant with that requirement. Okay. So capabilities and requirements pertain primarily to message layer security and also to transport level security. So you can, as I mentioned before, you can actually have a message level security, like what I'm talking about is a SOAP message level security, or you can actually have transport level security, for example HTTPS. Okay, so these things could be specified in WSDL document. Okay, so continuation. For example, examples of security requirements that can be specified through WS security policy might be something like this. Use of certificate and private key pair or valid username and password in order to authenticate to a service. So your web service can specify, in order to talk to me, I'm asking my clients to use a certificate, okay, or username and password, or even combination of those two. Okay. I can also specify the type of key and key size and algorithms. Okay, so the key size certainly will actually impact how secure your web service is going to be. All right, so moving forward, another set of another set of specification is the WS trust. Okay. And then we'll talk about the concept of STS, Security Token Service. Okay, so before I move on, let me see if there are any questions. So WS Trust and Security Token Service. So WS Trust specification defines a scheme for delegating authentication and authorization and user identity mapping management service to another external service. And this another external service is called the Security Token Service. So basically, this is a third-party security service, for authentication and authorization, and and other security services. So let's see how these things should work. Suppose we have a web service client here, and then web services provider endpoint here, and what in this case, endpoint is going to ask to the client is if this service is designed in a way that this service asks for the client to get security token from the security token service. Okay, then the security token service is providing the security service such as authentication and access control and things like that. So this client trying to communicate with the endpoint first, and then endpoint will say, in order to communicate with me, you have to get security token from security token service. So client is going to, number 3, talking to security token service to get the security token, and then security token service it will initiate the conversation, and then 5 and 6 is going to be in fact getting the security token, and then client will send the request along with the security token from the security token service, and then endpoint will allow it. Okay. So these are the steps of control flow I just mentioned. So in step 1.2, the client sends message exchange request to the service to obtain the service WSDL with the security policy. So it will try to get a WSDL document from the service endpoint, and then WSDL says, in order to communicate with me, you have to get security token from STS. So now it's going to communicate with STS, and it knows how to communicate with the STS. Again, it will try to get the STS's WSDL document, and then it will communicate. The next step is then it will try to send request security token to STS and receive request service token response, which actually includes the security token. And then client will actually send that security token to the service, and the service will actually authenticate, and it also will check the access control, and then will allow the client to access the resource. So basically, this is the how the STS is involved. STS is, you can think of again, third-party security service provider. So you can think of this one. The scenario is something like this. You probably have seen in your access some services on the net these days. It asks you, it gives actually in fact a couple of options. One option is registering to them so that they can actually authenticate you, or they might actually ask you to authenticate using your Facebook account or Twitter account, right? So in that case, Facebook and Twitter is playing the role of, in a sense, STS. Okay, so hopefully that gives you a sense of how the role of STS is actually being played. Okay, all right. In fact, that's a perfect example of security token service. All right, so brokered trust. Broker trust is something like when application have to use multiple security domains where each domain has its own security token service. So let me see, I have a picture. Looks like I don't have a picture. So examples like this is, oops, sorry. Suppose if your application has to work with your application is your service is actually being constrained by the Java-based security token service, and then your client is actually using .NET-based security domain. So by different security domain, you are talking about the different security domain technology is actually being used. Okay, one is using Active Directory based security, and the other one is using covers, or the other one use. So when application is being involved with different types of security domains, then in each of the security domain there is going to be in its own STS. Okay. So when these multiple security domain services are being chained each other, so these multiple STSs can be chained with each other to broker trust among multiple security domains. So this pattern is called the brokered trust. So if your client is .NET client, then this .NET client actually, before it's communicating with a Java-based web service, it will try to communicate with your .NET STS. And then that .NET STS is communicate with the Java STS, and then Java STS will communicate with the Java web service endpoint. Okay, so multiple STSs, dealing with the different security domains are in fact work together to allow a client communicating with a server. Okay, so WS Trust basically defines a framework for that kind of brokering trust relationship between different trust domains. Okay. Okay, so next specification is WS Secure Conversation. This is actually this is actually for optimizing security in multiple message exchanges. So it basically establishes security session. Okay. The easiest way to understand how this secure conversation works is that how SSL works. SSL, if you see the handshake of how SSL is being supported, initially it's going to use a public and private key to create the session key. Okay, because the public key and private key scheme is very, very expensive. Okay. So what SSL does is, to use public and private key scheme to create the session key that is known to both clients and server, and then it's going to use that the session key for encryption from that point on. So that's going to be a lot more efficient. So that's basically what it does with the WSIT Secure conversation. It's going to actually create the session key that is actually common using that is actually used as the private key between the two communicating partners. Okay, client and server. Okay, just give you a sense of the concept of it. Let's see. So I'm going to just move ahead on this one. Alright, so I'm going to actually move forward with the security profiles. So what is and why with WSIT security profiles or security mechanisms? So the reason there are many security profiles is because there are many different ways of actually providing security. So WSIT makes securing web services easier by including set of pre-configured security profiles or security mechanisms that can be applied to web service and client. Okay, and this security feature can be set on an endpoint or per operation basis. So you can have a very fine-grained way of actually applying security profile. But usually you are going to actually apply on endpoint basis. And so security headers in the SOAP message or XPath identified elements may be signed or encrypted. So again, as I said before, you can have a fine-grained way of actually the encrypting and making a signature out of it. Instead of actually SSL is all or nothing. Instead, in SOAP, you have a fine-grained way of actually signing and encrypting. So it's a lot more efficient. Okay, so WSIT and Web Services Security Policy and WSDL. So all these security features you choose is going to be in WSDL document. Okay, so just like any other WSIT features is going to be eventually specified in the WSDL document. Okay, all right. So NetBeans support this WSIT security. Again, it lets you create this configuration file, WSIT configuration file, which is going to be merged into final WSDL document. Okay, so NetBeans provides a set of security profiles for configuring security at service endpoint or client. So these profiles allow a developer to select integrity and confidentiality of a message, and developer can also choose a token format. So basically there are a bunch of security schemes you can choose, and for each of those security schemes it also provides a fine-grained control. That's basically what it's talking about. Okay, so let's actually go over some of the WSIT security profiles or mechanisms. So these are the set of WSIT security profiles. So we're going to actually deal with just these two in our lab. Okay, so username authentication and symmetric keys. We're going to actually talk about this one in a bit more detail in the following slide. So you are going to authenticate using username and password. Okay, and then after authentication, the server will actually create the symmetric key, and that symmetric key is going to be used for the subsequent communication. Okay, that's username authentication and symmetric key. Mutual certificate security is that both client and server should use a certificate as a way of actually authenticating. Okay, so in this case, you are using username and password for authentication, But for encryption and everything after that, you're going to use a symmetric key that gets generated after authentication. In this case, you're using client the certificate. It's a mutual certificate security. What that means is that client will use a certificate for authentication, and the server will use server also will use authenticate for authentication to the client. Okay. Transport level security is just SSL. Okay. Message authentication over SSL is basically a combination of the SOAP message level authentication plus SSL. So it will actually use SSL as an encryption, and then it will use a SOAP level authentication. SAML is another standard on the internet. It stands for Security Assertion Markup Language. This is actually used for authorization and over SSL, and then endorsing certificate, and a bunch of other options. And last, there is actually STS. So this is the case that STS is involved. Okay, so just to consider, these are different ways of security different ways that security is being provided. Okay, so again, we're going to actually mostly focus on these two. So in terms of the criteria that you are going to use for selecting a security profile among these security profile, there are a few things that you want to consider. The security layer, whether you want to support transport level security, which is SSL, or messaging level security, which is a SOAP messaging layer, or a combination of these two. Okay. And the type of client credentials, username and password is one type of client credentials, and X.509 is another type of credentials. SAML assertion, or the token from STS, is another client credentials. Okay, so by client credentials is basically identifying the particular entity. Okay, so we are mostly familiar with the username and password as a way of identifying a human being, right? Okay, but you cannot use username and password for web service client. Application entity cannot use your username and password. So in that case, that application has to use X.509 certificate as a way of identifying itself. Okay. And the role of the client credential played in securing message. So as supporting token or primary securing token, in case of supporting token, messages are usually secured with the server's X.509. So so this is where the third party actually kind of getting involved. So let's actually talk about those two schemes we are going to actually play around in our hands-on lab. Username authentication with symmetric keys. So here it supports integrity and confidentiality using symmetric keys. So basically it's going to use username and password for authentication. Okay, so in this case, client does not have to have a certificate because it's using username and password as an authentication. So once authentication is done, then a symmetric key is going to be created by the server, and that symmetric key is going to be used for integrity and confidentiality. Okay, so it's going to create the hash map for integrity, and then it's going to encrypt the data for confidentiality or privacy. Okay, so the symmetric key cryptography relies on a single shared secret key that is used to encrypt the message. So based on username and password, it's going to create this secret key called the symmetric key. That is the same thing. And so this shared and symmetric key is generated at runtime and encrypted using services certificate. Okay, so when this symmetric key is actually generated at the server and has to be sent to the client, it has to be encrypted by services certificate, meaning services public key. Okay, so the service must specify alias in the key store. So in order to encrypt it, it's going to use the private key of the server. So that private key has to be maintained in the key store in the server. Okay, now the client has to have a trust store identifying server's public key. Okay, what it means is that the client, in order to verify the encrypted session key, encrypted secret key, when it actually received the encrypted secret key from the server, it has to have a way of verifying that this is in fact coming from the server it claims it is. Okay, one way it can verify is to see whether the public key it has in its trust store is in fact used to decrypt the symmetric key encrypted by the server's private key. Okay, yeah, so maybe you guys may be a little bit confused on this one. Let me see if I can explain this one better. Alright, so let me actually explain this one more time. We're using another example. This is actually, happening everyday life. When you are using some kind of online shopping site, whether that is Amazon.com or whether that is Flickr, when you actually sign up, you have to send your credit card information, right? So this is actually how SSL works between your browser and your online shopping site or your bank. So bank is probably better deal. So when you're trying to communicate with your bank, okay, the SSL gets started because you're actually entering the secure space of your banking application. Now, when your browser receives some kind of response from the server, there is a question: how does a browser know? Meaning, how does browser know that the message it has received, meaning response message it has received from the server, is in fact from the server it claims it is? Suppose I receive a message from the Bank of America indicating, yes, I'm Bank of America, right? How do I know? Okay, how do I know that it is in fact the message from Bank of America? Okay, all right, I'm gonna actually ask you guys to answer that question. Anybody can answer that question? How does my browser knows the message that it received from supposedly from Bank of America is in fact from Bank of America? Yeah, okay, so Ni actually answered the question. CA, the certificate. Yes, that's how what happens is that the server will actually send a message in the signed by signed by this private key, okay, and then the browser has all the public keys of actually, let me actually repeat. Okay, the server will send a message that is signed by itself, its private key. Okay, and so when the browser receives that message, okay, it has to have a verify it is in fact the one from the Bank of America. Okay, now this is where the certificate authority is involved. Okay, so the browser actually has all the public keys that are signed by the security, certificate authorities. So by actually taking a look at the security authority chain, it can actually verify is in fact the Bank of America. So that's basically what it does with this key store and trust store. So key store, I think I'm gonna actually explain this one more time when we do the hands-on lab. Key store is where you are going to maintain your private key. Trust store is where you are going to maintain your public keys of your communicating partners. Okay, so in this case, client, when it actually receives this symmetric key to verify this is in fact really from the server, it's going to actually use the public key that is maintained in the trust store of the server. Okay, so that's basically the basics of private key and public key schemes. Alright, so mutual certificate security. So it supports integrity and confidentiality of the messages, and also support the authentication. In this case, it's using authentication by using certificates. So in this case, it's a mutual certificate. In previous case, this is the case that where the server has to actually have a certificate. Okay, as a way of identifying itself to the client. Okay, and client authentication to the server is done through the username and password. In this case, both parties are using certificate as a way of authenticating himself to the other party. Okay, so in this case, both parties should have a key store and a trust store. Okay, so again, key store is a database of private keys. Okay, and the trust store is a database of trusted entities, meaning they are public keys in the form of certificates. Okay. SSL is probably something we already know. So security is provided at the transport layer, and again, we are talking about mostly HTTPS. So transport security is a point-to-point security scheme that can be used for authentication, integrity, and confidentiality. So when running over SSL protected session, the server and client negotiate an encryption algorithm and cryptographic keys. The security is alive from the time data leaves the consumer until it. So this is another problem of SSL. So, SSL is actually on the wire protocol, on the wire security protocol. So, once the endpoint receives the message, then message is going to be decrypted, and then it's not protected, okay, unless you actually save it in encrypted form, okay. So this could be, in fact, another issue of using SSL, okay, because it doesn't provide the protection of the data once it's actually on the wire, okay. Okay, so digital certificates are necessary when running secure HTTP transport using secure socket layer. So again, this is actually something that we know about. Message authentication over SSL. So in this case, attach the cryptographically secured identity or authentication token with a message, or use SSL for confidentiality. So by default, username supporting token will be used for message authentication. So and in this case, SSL is involved. So I'm going to actually move forward because we don't have a lab for this. And basically, for now, you can think of STS is more or less third party that issue the security token. That actually provides, it plays a role. The security STS issue token is like a username and password. It's actually one of the authentication scheme. Okay. All right, so I felt like I've rushed a little bit here. Let's actually take a look at the hands-on lab documentation. Yeah, so the reason I actually kind of rushed a little bit is because I don't want to actually get into too much in detail. Without actually giving you some examples. So here we are going to actually talk about a bit more detail using at least two schemes, username and password, and as well as mutual certificate. And I'm going to actually explain one more time the concept of key store and trust store and things like that. Okay. So the first exercise is using username authentication with symmetric key scheme, and exercise 2 is mutual certificate security, and exercise 3 is a security STS security token service. Yeah, unfortunately, exercise 3 I have not finished. There was actually a problem in NetBeans to support this, so a couple of years ago I was not able to finish this one. I assume the problem of NetBeans is fixed, so I should actually complete this exercise, okay. But we are gonna do just exercise 1 and 2 today, okay. All right, so here we have to, in this case, since we are going to use a Glassfish, and since it's going to use username and password as an authentication, first we have to add a user to Glassfish security domain. So what you have to do is you are going to go, why don't I actually show it? Okay, let me just start the NetBeans. Yes. All right, so while it's being started, I'm going to show you in a few minutes once it's up. So basically you are going to start the Glassfish first, and then you are going to start admin console. Okay, and the admin console will prompt you to enter username and password. Okay, all right, so let's actually try that. Servers, and I'm going to start it first. Okay, so once you start it, then I'm gonna open admin console to add a new user. the new user we are going to add is WSIT user and change it. Okay, so in NetBeans, that is the default username and password is going to send as a test. Okay, all right. So let's see whether it's actually started. So basically, you are going to add admin and password is null. Okay. By the way, if you have installed the Glassfish as part of the NetBeans, you might actually experience this certificate has expired problem. Okay, in that case, you have to download new Glassfish from Glassfish website. Okay, unfortunately. Okay. Alright, so it's started. So let me see whether I can open the admin console. Oh, so it's not completely finished. And then we are going to add the user to file security domain. So you're going to expand the server config and security realms. It does provide several security realms. As a default, you're going to use a file security realm, meaning the security realm data is actually maintained in the in the file. Okay, and then we are going to add a user. Click Manage User, and you're going to add a user. So in this case, I have already added. So if you already have it, then you can skip it. Otherwise, you're going to add a new user. Okay. All right. So let's admin console. Yeah, if you have actually a problem like this, sometimes it happens. In that case, what you want to do is just go to this location directly. I think I specified right here. Okay, so then, yeah, so because I logged in before, it will actually got into the console right away. So here you are going to expand server config, and then expand security here, and then you are going to expand realms. Realm is basically it's a place where you are maintaining your security credentials. Okay, so here I'm going to select file and manage users. Okay, so there is no user is entered. So what you have to do is we have to enter user. Okay, so let me just okay, so I'm going to just so what we are going to do is basically here the new user we are going to add is WSIT user. Okay, yeah, so WSIT user, and the group is WSIT, and the password is change it. Okay, so I'm gonna use WSIT user. Oops. So this is your. I'm gonna go here. Okay, new. And user ID is WSIT user, and group ID is WSIT, and password is change it. Okay, and click OK. So the password do not match. All right, so let me just type again. Change it. Okay, so hopefully that matches. Oh, come on. So let me say CHANGEIT, and I guess I have to type this one more time. CHANGEIT. Okay, so now it created the user. Okay, so then what we are going to do is we are going to restart the Glassfish, because we need this Glassfish to restart with the newly created security realm. Okay, and then we are going to configure Hello Web Service to use security. Okay, so you have a Hello World service that you worked with the reliable messaging, or you can just open the one from the samples directory of this hands-on lab. So I'm gonna actually do that. Okay. So here you are going to edit web service attribute. Okay. And then we are going to set security attributes. Okay, so first, if you're using the same application that you have used in reliable messaging, just for the sake of this exercise, just uncheck it, because we do not want to mix up with reliable messaging with the security information. Okay, and then you are going to select security service, and then among all the security profiles or security mechanisms, you are going to select username authentication with symmetric key. Okay, so this is basically the default is going to display. But if you click here, you are going to see a lot of other the security mechanisms you can pick and choose. Okay, so let me just open the project and let's see. I'm gonna open Hello Web Services. I'm gonna actually use my lab. Okay, because I don't want to change my labs, and I'm gonna just use this too. Okay, so let me just continue. So you select the username authentication with the symmetric key, and then you select user development defaults. Yeah, so this is the NetBeans provided development feature that when you're using this one, it's going to set everything for you, so you can actually test this one. Okay, and because you're using security, you have to use the addressing. Okay, so that is actually automatically be selected. Okay. Now this is what happens when you select user development defaults. Okay, so let me see whether I can do these things. So I go to Hello Web Service, and then Web Service here, and right click, and if I click Edit Web Service Attributes. Okay, so here I'm gonna select this guy, click yes, and then you can see, and then I'm going to select use, and here you can see that a bunch of security profiles you can choose. Okay, so here I'm using username authentication with a symmetric key. Okay, so what it means is that client authentication to the server is done by username and password, but the server authentication to the client is done through the certificate, as we actually talked about with the browser and Bank of America example. And then the symmetric key is created by the server and sent to the client. So that's the one they're gonna use for the privacy as well as data integrity. Now, when you select the this use development defaults, what happens underneath is that key store configuration is set as in location. So it's basically key store, the configuration is set with keystore.jks file. Okay, this is the private key store for the server. Okay, and so this is the server has to actually sign with this private key, right? So that's the reason it has to have a keystore.jks file. Okay, then once you've done it, you can actually see. So once it's done it, okay, let's see. You can see now. You can see on the WebINF, this configuration file is created. Okay, so if you take a look at the web pages WebINF, this file has been created. Okay, so again, this is the fragment of WSDL which actually reflects the security schemes that you chose. Okay, so this will be merged with the WSDL. Okay, all right. And here you can see protection token part is the secured with X.509. Okay, and key store part, which gives the location of the key store. Okay, and so this is basically so this is the key store. This is basically the location of the private key on the server side. Okay, that is going to be used by the server. Okay, and then when you deploy the application, you are going to see WSDL document is actually being displayed like this. Okay, so let's actually run this guy. So I'm going to just run this guy, and it will display WSDL. Okay, like this. And then 1.3, you are going to rebuild the client. Now, the client is not just the WSDL document, refreshing things. It has to do a couple more. Okay, so let's see whether this one reflects. Oops. So okay, so I have to say WSDL somewhere here. So hello service, the WSDL. So. Let's see, hello web service, hello service WSDL. Hello service WSDL. Yeah, I'm not sure whether that looks fine. Hello service. That's not good. Let's see whether it has. Oh, okay. So it's actually deployed in Tomcat. So let me actually redeploy. Oh, I see. So this is yeah. It's possible that Tomcat does not actually expose this guy with the WSDL. So I'm gonna actually run this guy on the Glassfish. Okay. So I'm going to set the properties and select run, and then instead of Tomcat I'm going to select Glassfish 4 and okay, and run. Not good, so let's actually clean build. I'm going to just stop. Yeah, I didn't have to stop Tomcat because it's using a different port, but just in case. Okay, let's do the clean build. Okay, and now let's run it. What is going on here? All right. Okay, it's the same URL pattern. Okay, yeah, it looks like some okay. So I'm gonna actually it looks like there is actually a application that is already deployed. So I'm going to go over here, and I'm going to just undeploy all this application. Okay, and now let's try again. Okay, and let me try one last time. I'm going to stop and restart. Let's just clear this guy, see whether things are working as expected. Did I actually? Okay, so let's start again. Alright, so it started. Let's see, there is nothing here. Alright, so let's try to run this guy one more time. Why is having a problem? same URL. I thought I actually cleaned it up. Alright, I'm gonna actually restart NetBeans. Yeah, it seems like it's actually thinks that another application is actually deployed. So let me just continue. Hopefully you guys have a better luck. I'll try again while you guys doing again. So here we have to recreate the client. Okay, so we have to first of all refresh WSDL, and this is the same drill that we have done. So it's going to generate code and compile the code and everything. Okay, now you have to configure client as well. So here you are going to select the on the client web service client and edit web service attributes. Okay, so here you are going to select use development defaults. So what it does is it's going to actually send this username and password, WSIT user and default password. Again, this is kind of development convenience scheme so that you can test this feature with a minimum configuration. Okay, and then then you have to actually set the trust store location. So see, basically, yeah. So what it does is that it set the trust location. If you want to see how it is done, you can just uncheck and you can actually set it yourself. Okay. So by checking it, it does set the trust store for you. So if you actually uncheck it and see, this is the default values that are being used when you select the use development defaults. So basically setting the default and username, and the location is actually something that you can specify. This is basically where this trust store file is actually being located. You go to Glassfish directory and Glassfish domains 1 and config, and then you select the certificates. Okay, and then you select the alias, which is the security server. So right now we're actually using a single machine, right? Okay, so we're actually sharing the same security key store and trust store. So in this case, we're actually selecting as a client. Client needs to have the public key certificate information of the server, so that's the reason we're actually selecting it. Okay, and you have to also select the alias. Okay, and then basically you can clean build, and then you run the application. Then you are going to actually see the same result, but behind the scene, what has to happen is whenever you have a problem, you're going to actually see a fault from the server. Okay, so when things worked okay, then you are going to see this SOAP message, which contains all the security, sending to the server. Server actually responds back, okay, with the response that contains all the security information. But the end result is going to be, you can actually see these hello sanction things right here. Okay, all right. That is the authentication with the symmetric key. Okay, I mean, all these things, is just for your reference. I mean, you don't have to understand all this nitty-gritty. These are all specified in XML security and encryption standard. Okay, and exercise 2 is, this is actually the case that you are using even for certificate as a client authenticating itself to the server. So in exercise 1, client was using username and password as authentication to the server, while the server is using certificate as a way of authenticating itself to the client. In this case, both parties are actually using certificate. Okay, so here you are going to configure the hello web service. Okay, to use this time the mutual certificate security. And here you are going to uncheck it because you're not going to use the development defaults. Development defaults is basically, in this case, sending username and password. Okay, so uncheck this guy, and then you are going to configure. Okay, and here we are going to, the mutual certificate security algorithm and header count. These are all default. You can just take it, and now you're going to actually configure key store. Okay, so this is a key store from the server side. So the key store, and again, you actually go to exactly the same location. Okay, and then you configure trust store as well. Okay, again, you go to the same place. Okay, and yeah, so and then basically, you know, you're gonna actually deploy the application, run the application, and again you're gonna actually see WSDL document like this. Okay, and let's see, and then from the client, we are going to refresh first of all. Okay, and then this guy has to configure key store as well, because now the client also has to provide a certificate. The also has to use the certificate to be authenticated to the server. So you know, it has to use this private key to you know, to sign it. Okay, so it has to set its own key store. So you say key store, and again you go to, you know, the same place. Okay, so we're actually using the same key store files and the trust files, both client and server. Okay, because we are using a single machine, but in general you probably want to use a different machines, different files, and then also configure the trust source. So you can see the difference between exercise 1 and exercise 2 here is that in exercise 1 you don't have to actually configure your own key store and trust store for client. Now here you have to, because now you are using certificate as a way of authenticating to the server from the client. Okay, so basically, you know, the configuring key store and trust store. Okay, same procedure you've done for the server. Okay, and then when you run the client application, then it should actually work as expected. And again, you should actually see, you should see this messages. Okay. Now I have to warn you, this has to be exactly step by step as documented. If you make a single mistake, you are not going to actually see the result. Okay, so you are going to experience some errors here and there, as I actually have done in my case. So I'm going to actually try again from the beginning and see, you know, step by step. But you know, if you actually experience a problem, just go back and try again. Okay, to make sure you follow the step by step. Okay. All right, so I'm going to give you guys enough time until you succeed, in fact. So I'm going to give you about 30 minutes, the minimum, and you know, we'll see what happens. Okay. All right, so I'm going to just stop the recording.